Essay 102, Three-Dimensional Orbits in Galaxies. Contemporary astronomy observes a myriad of galactic structures in which stars orbit a very heavy central mass m. It is accepted that the Einstein General Relativity is wildly wrong, so it is quite obvious to any layman that there are no black holes. It is not yet obvious to dogmatists with omelettes on their countenances. The central mass cannot be a black hole because the black hole is an erroneous claim made by dogmatists who adhere to an erroneous geometry. The second Bianchi identity upon which Einstein based his field equation directly, UFT 88, now a classic paper. It is also quite obvious to any layman that these orbits are three-dimensional, but not to the dogmatists who see no ships. The only thing they see is an event horizon, another regrettable howler that any wolf would have been proud of. Therefore, the general explanation of three-dimensional galactic orbits requires the spherical polar coordinates and the kinetic energy of the Hamiltonian and Lagrangian in classical dynamics. Once this self-evident adjustment is made to 400-year-old groupthink, the resulting three-dimensional orbits can be graphed and classified in various ways, introducing the required myriad of three-dimensional possibilities instead of sticking to the boring old two-dimensional plane, or what was thought to be a plane. The classifications of the orbits are given in UFT 269 and following on AIAS.us in terms of the spherical polar plots and Cartesian solid geometry. The Whirlpool Galaxy is the most spectacular, and images of it have been syndicated worldwide for years. This object appears to be roughly planar, but that again is a mirage. Its correct description needs 3 dimensions. Obviously, in retrospect as usual, a Whirlpool Galaxy is situated manifestly in the 3 dimensions of space within the context again of classical physics. Space is 3-dimensional and not 2-dimensional. We can now explain a great deal we could not before with classical physics, and need only special relativity when required. For example, Thomas precession theory, UFT 265 and 276, Einsteinian general relativity is no longer needed at all. It is a good idea not to use a theory which half the geometry is missing. Einstein's omission of torsion leads to the inconvenient fact that it fails completely to describe Whirlpool galaxies. This is another omelette on the countenance of those who refuse to countenance change. In other words, the Einstein theory fails qualitatively in Whirlpool galaxies, whereas the ECE theory offers a simple explanation of them according to Baconian principles and Occam's razor. The new 3-dimensional orbit theory offers a lot more information about the Whirlpool Galaxy. This has been demonstrated in recent papers by using an inverse cube law of attraction between an orbiting star of mass m and the central mass m of the galaxy. One could argue that this is simplistic. Galaxies are much more complicated than that. But Occam's razor is simple-minded, and we need to begin again at the beginning, like under Mirkwood. The inverse cube law of attraction leads to the hyperbolic spiral orbit that is spectacularly evident in the Hubble Space Telescope. In 3-dimensional orbit theory, the spiral's orientation depends on the ratio of L to L sub z, the new universal law of planetary precession. There is much more to a 3-dimensional spiral than meets the eye. To generate the 3D Whirlpool Galaxy from the 2D Whirlpool Galaxy, the inverse cube law of attraction remains the same. So the potential energy remains the same, but the kinetic energy is described by spherical instead of plain polar coordinates. Very obvious and very much in retrospect. Looking forward, it was not obvious for 400 years. There are many different shapes of three-dimensional galaxy, for example, nearly spherical to cigar-shaped, extended ellipsoidal, and so on. So it becomes obvious, and again in retrospect, to apply 3D orbital theory to 3D orbits of stars around a central mass M in a galaxy. One recent paper, UFT 269, and following in the series of that series, gives a sample of 16 classifications of three-dimensional orbits using Cartesian coordinates of solid geometry. These represent the three-dimensional conic sections of three-dimensional orbit theory. A new world of orbits becomes vividly apparent, and the 400-year-old flatlander has had his day. To those with omelette all over them, the world is still flat.